Good morning, dear students. Welcome back to physics class. In today's class, I would like to discuss on two topics. They are A. Anomalous behavior of water, and B. Heat capacity, specific heat capacity and molar specific heat capacity. First topic is anomalous behavior of water. What is anomalous behavior of water? It is one distinguishable property of water. When water is heated at 0 degrees Celsius, it contracts instead of expanding, and it will happen till it reaches at 4 degrees Celsius. So, the volume of given amount of water is minimum at 4 degrees Celsius. Therefore, its density is maximum, since density is equal to mass per unit volume. This also means that when water at 4 degrees Celsius is allowed to cool till it reaches at 0 degrees Celsius, this will expand instead of contraction. This is a reverse process. This expansion is called anomalous expansion of water. When water at 4 degrees Celsius is heated, it will start expanding. That is, above 4 degrees Celsius, the volume of water will increase, and therefore its density will decrease. This means that water has maximum density at 4 degrees Celsius. This anomalous behavior of water is shown in given graph. The graph is plotted by taking temperature along x-axis and volume of water along y-axis. Let us think about what is the advantage of anomalous behavior of water. Because of this property, animal and plant life in a lake or a pond would be possible. How can it be possible? When a lake or pond cools towards 4 degrees Celsius, water near its surface loses energy to atmosphere. Then what will happen to the water on top surface? Its density is decreased. Then it sinks. The warmer, less dense water near the bottom rises. However, once the colder water on the top reaches the temperature below 4 degrees Celsius, it becomes less dense and remains at the surface, where freezing will take place. You know that water at 4 degrees Celsius is maximum density, and this highest density region will occupy in bottom surface. Because of this property, water in lakes and ponds freeze only at the top layer, and at the bottom it does not happen. But if the water freezes at the bottom also, then animal and plant life would not be possible. So, when water on top surface freezes, it insulates the water below it from the outside, which acts like a blanket. Due to this property, many fish can survive in the winter season. If you plot a graph by taking temperature on x-axis and density on y-axis, you will get the graph as shown in given figure. The information that you get from the graph is that the density of water increases as its temperature rises from 0 degrees Celsius to 4 degrees Celsius, and its density decreases after 4 degrees Celsius. You have to understand that after 4 degrees Celsius, density of water is decreased due to the increase in volume of water, as density is equal to mass divided by volume. Let us see how to derive a relation between coefficient of linear expansion alpha L and coefficient of volume expansion alpha V. For this, we have to consider a block of cube. Initially, its length is L. Suppose its temperature is increased from T to T plus delta T. As a result, its length will increase from L to L plus delta L. We have the expression coefficient of linear expansion alpha L is equal to delta L by L divided by delta T. Then delta L is equal to alpha L into L delta T, which is the expression 1. You know volume of a cube of side L is equal to side into side into side. It is L cube. So V is equal to L cube. Then what will be V plus delta V? It will be equal to L plus delta L all cube. Since a plus b the whole cube is equal to a cube plus 3ab into a plus b cube, by solving the expression for delta v, we get delta v is equal to 3l square into delta l. Here we have neglected delta l square and delta l cube as they are very small as compared to L. Here we get the expression delta V is equal to 3L square delta L, which is the expression 2. From the expression 2, we can write delta V is equal to 3L square into L delta L by L, which is equal to 3L cube delta L by L. Since L cube is equal to V, so the expression will become as 3V delta L by L. Delta V is equal to 3V delta L by L. From the expression 1, delta L by L is equal to alpha L delta T. So, delta V will be equal to 3V alpha L delta T. From this expression, 3 alpha L is equal to delta V by delta T. It is alpha V, the coefficient of cubical expansion. Then alpha V is equal to 3 alpha L. It is the relation between coefficient of volume expansion and coefficient of linear expansion. Let's learn about thermal stress. What is thermal stress? You know that when an object is heated, it will expand. If it is cooled, it will contract. But if for some reason, if the object is not allowed to expand or to contract, under that case, mechanical stress is induced in the body, which is known as thermal stress. It is the mechanical stress induced by a body when some or all of its parts are not free to expand or to contract in response to change in temperature. Examples: while designing structures like concrete highways, gaps are left which are filled with some flexible material so that concrete is allowed to expand or contract. You may have noticed there is a small gap provided between the rail joints. Why does it do so? Can you say about its reason? By doing so, it allows the free longitudinal thermal expansion of rails on hot days. On next, you are going to study about heat capacity, specific heat capacity and molar specific heat capacity. First one is heat capacity. What is heat capacity? When a given quantity of heat is absorbed or rejected by a substance, the change in temperature of the substance occurs is characterized by a quantity which is called heat capacity of that substance. It is the ratio of amount of heat energy supplied to the substance to change in its temperature. It is denoted by S. It is mathematically expressed as S is equal to delta Q by delta T, where delta Q be the amount of heat supplied to the object and delta T be the change in its temperature. Second one is specific heat capacity. What is specific heat capacity of a substance? Suppose if equal amount of heat is supplied to equal masses of different substances, what should be the resulting temperature changes? If the temperature changes will be same or not? They are not same. It shows that every substance has a unique value for amount of heat absorbed or given off to change the temperature change. The amount of heat energy absorbed or given off by unit mass of substance divided by change in its temperature is called its specific heat capacity. So, specific heat capacities of different substances are quite different. Then, specific heat capacity is defined as ratio of amount of heat energy absorbed or rejected per unit mass of a substance to change its temperature. This ratio is equivalent to heat capacity divided by mass of a given substance. Specific heat capacity is denoted by small letter s. How can it express mathematically? It can be written as small letter s is equal to capital letter S divided by m, which is equal to delta Q by m delta T, where delta Q be the amount of heat energy absorbed or rejected by the substance, m be the mass of the substance, delta T be the change in temperature, and capital letter S be the heat capacity of the substance. It depends on nature of a substance and its temperature. SI unit of specific heat capacity is joule per kilogram per Kelvin. And third one is molar specific heat capacity. Heat capacity per mole of a substance is called molar specific heat capacity. It is the ratio of amount of heat energy absorbed or rejected per unit mole of a substance to change its temperature. It is denoted by capital letter C. It can be written as C is equal to S by nu, which is equal to delta Q by nu delta T, where nu be the amount of substance expressed in unit of moles, C be the molar specific heat capacity of the substance, delta Q be the amount of heat absorbed or rejected by the substance, delta T be the temperature change, and S be the heat capacity of the substance. It also depends on nature of a substance and its temperature. SI unit of molar specific heat capacity is joule per mole per Kelvin. What are molar specific heat capacity at constant pressure and molar specific heat capacity at constant volume? If a gas is held under constant pressure during heat transfer, then the corresponding molar specific heat capacity is called molar specific heat capacity at constant pressure. It is denoted by Cp. And if volume of a gas is maintained constant during heat transfer, then corresponding molar specific heat capacity is called molar specific heat capacity at constant volume. It is denoted by Cv. Water has highest specific heat capacity. It is about 4186 joule per mole per Kelvin. Have any important application of water due to this property? Yes, it is used as a coolant in automobile radiators and in hot water bikes. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.